Hello, welcome to the channel. So we've got a Fender Deluxe Reverb amp here, and obviously this is one of the modern reissues. It's not a vintage one. It's still a very nice amp though, and this is in because it's occasionally blowing the power fuse, so the mains fuse. So we're going to have a look, see if we can see anything wrong with it. There's obviously something wrong with it. So I'm sure everyone's seen these before, but we've basically got a couple of channels: volume, treble and bass, and we've got a custom channel and a vintage channel on this one. Volume, treble, bass, reverb, and then we've got the speed and intensity on the tremolo. So let's have a look at the back. So there, looking in the back, you can see we've got a Celestion G12 70 watt in there, so that's quite nice. We've got on the backs, we've got on off switch and standby. Got these nice rubber covers on there, power fuse, we've got speaker sockets, and that is the foot switch on there. So pretty simple on the back. Tubes in there, they look like JJ's to me at a glance, but it's only a glance till we get the cover off. So let's just have a look at this fuse. Not blown at the minute, and I did plug this in when the customer brought it to me, and it did fire up okay. So some kind of intermittent fault. It does get quite noisy apparently, I think the customer said. It's a couple of weeks since he bought this in, so well, it could be a tube that's on its way out, or it could be the power transformer, of course. So we're hoping that's not the case. Right, so check the fuse, and that is a quick blow 1 amp, so that's fine. So what we're going to do is switch on, and we're not on the current limiter because obviously if there's a problem, the fuse blowing, the current limiter will prevent that. So we need to find this fault. Right, so we're just going to switch off. Just want to monitor the, just let it run down a bit. So I don't see a massive increase in current for a second when it's switched on the meter. You know, it's not sort of flashing up to 1 or 2 amps, so that's a good sign, but that still doesn't mean there isn't a problem with the transformer, but at least that's a start. So let's turn it round, switch it off first. So we turn on again. Oh. Oh, has it popped the fuse? It's popped the fuse. Now that doesn't look particularly black inside or anything. Just see if we can get, but it's blown, madam, like Mrs. Blenkinsop's TV. It's blown. Right, so it's back on, and I've just put a 500 milliamp in there, and it's not blown that. Right, so we've got the cover off there, and it looks like we've got a new set of JJ's in this. Yeah, and they're not excessively biased. They're not that warm. They're not, you know, they're not. See, I can keep my hand on those. They could well be under biased there. They could be a bit cold. You know, if you open this up and one of those is all dark red, or you know, or it starts to turn white eventually, then you know you're looking at, but this looks to be running fine. So I've just darkened things a little bit there, and I'm going to, because I want to just see if there's a flash over in these tubes when we turn, in this rectifier tube when we turn on. And again, I've just turned that on with the standby at the same time there, and I've only got a 500 milliamp fuse in there, and it's not blown that. So that could be a tricky fault to find. So this amp, really, you know, when you switch it on, I mean, some amps, a lot of amps, you see it on the current limiter bulbs, they'll flash up bright for a second with, you know, with that surge of current when you first switch on an amp you get with a transformer, but not on this amp. So let's turn the standby off. Oh, sorry, I've turned the whole amp off again. Now that's popped the fuse, and I just heard something go there. Right, so we've got it out on the bench now, the chassis, and there's something on there, on a bit of masking tape. I'm not quite sure what that is. There's a sad face and an arrow pointing to something. I don't know what that says. El panel. It's like something in Spanish. This amp was made in Mexico, but I'm sure that wasn't put on it. Right, so we've got it on the bench. You see that? Just there. Burnage. So this is another nighttime assessment video that I'm doing, and I thought I'd do an assessment on this, see what was wrong. If it was something simple, I can fix it there and then get it back to the customer. I've got some restorations going on, and I've got the Univox U50 that we looked at, the solid state amp. I've nearly finished that now, waiting for some more parts. There's still one or two problems with that, and I'm also working on the one of the Masco amp, the MA17N. That needs some tube sockets fitting and stuff, so that's in the pipeline. And also the Ampeg Rocket reverb that we looked at, or reverb rocket, I always get that the wrong way around. Also, I've started work on that, and I'm nibbling through that, trying to get that done. That's one of Lee's amps from the shop. So just putting some night shifts in at the minute. Anyway, enough waffling. Kind of think that that's been burnt with a soldering iron to get that in there. A very crude way of repairing it. But anyway, that's the least of his problems. I don't think it's the power transformer, because when I was switching this on, I'd expect to see much bigger surges on the current meter. You know, 1.5 amps, even 2 amps. That's usually typical of a transformer if it's got short in turns, but nothing excessive. 500 milliamps surge when you switch an amp on is not a lot, is it? So is that JJ5AR4 GZ34, is that on its way out? Right, so it blew the 500 milliamp fuse I'd put in, and I put a 1 amp fuse back in, and I've been at it now for about 10 or 15 minutes, and it's not blown at all. So I don't know. I took the doghouse off to see if there's a problem under there, and you can see we've got the IC caps in there, but it won't take long to swap those, so it's probably a good idea to change them. I mean, it's, you know, off 3/4 of an hour, and those will be changed and done, and the lid will be back on it. So that's I think probably have a word with the customer about that. So I suppose all we can do is just keep on with it. And so what I've done is I've been pulling the plug, plugging it in, leaving it for a couple of minutes, pulling the plug out, putting the plug back in, and the fuse hasn't blown. And then I've been using the switches to see if there's a problem in the switch. Is the switch arcing across inside? But nothing. It hasn't, this time it hasn't blown. So I can't find anything wrong with this amp. I mean, we've only found that ribbon plug and there, but obviously there's no high voltage on that, so that's not causing any issues. And I think that's just been burnt in with a soldering iron. That's what I think with that. Right, so we're just going to switch on. So the other thing is we're on a GZ34, so 5AR4, so that's a slow start tube, rectifier tube. So, you know, we're not getting a massive surge of plate voltage on these tubes. It's coming up gradually. So, you know, this we're looking for this on the primary side, really, you know, up to the AC on the rectifier tube. And again, because remember, this fuse only blows, this fuse blows as soon as it's switched on. So the tubes aren't conducting at that point because the rectifier tube hasn't started conducting, so the output tubes won't be conducting. So that means that, you know, whatever's causing that, it's probably not the tubes. Again, the capacitors won't be seeing any voltage till the GZ34 begins to conduct. So it's kind of pointing to this tube if there's a problem, or the transformer. Don't think it's the transformer because, as I say, with shorting turns you tend to see that surge of current. Right, so I've done a bit more research on this amp, and this amp is a 68 custom reissue, and I've got the schematic for it, because I spotted a few mods on here, what look like mods. They turned out they are mods. Yes, pink. I can hear pink now in there. So if we look at this wire here, we can see this resistor that's missing is R12, and this R12 has been connected to R53. And R53 is the grid. R53 is connected to the grid on the side of the phase inverter. So the channels go in on one side, they're mixed with two 220k resistors, and then the other grid usually goes to ground. Otherwise it's just an open grid. And R53 is a 220k resistor, and R12 was a 220k resistor. They were mixer resistors. So if we look at such as this, and Pink's tail keeps flashing past, you know, we've got the layout there, and you can just see the capacitor board there because I've enlarged these, but we've not got that board that's on the side there, and you probably can't see it because it's not in shot. Just ease the camera around so you can see that board there. You just put one light on there, so you can see that board is there. That's not on the schematic, but there is some revisions and some mention of it, I think. Now the other thing is 4 wires have been snipped off here, or 3 or 4. And you can see the blue insulation there and the red insulation. So there's been some wires snipped off of there. Now this amp's been to a previous tech, and that tech modified the tremolo, because apparently, from what it says on the receipt, Pink, don't do that please, what it says on the invoice, it says that he fitted this octocoupler, and I can't quite, it's a bit sketchy what he's actually put on there, so I can't quite make that out. And apparently, and I'm not naming names or anything, but he's the only guy that's been in here, and all he's done is this mod on the tremolo. So these mods, he hasn't done them, and no one else has been in this amp, because if he'd have done these, he'd have put them on his receipt, obviously on his invoice. So he's not done that, and that looks like factory to me. If you look at this cable and then look at this cable that they're using here, on these preamp tubes, it's the same cable. There's also another one there somewhere. There was another here, so there's a so started investigating what was actually going on there. It's a good job this amp's not switched on, Pink, isn't it? With your tail over the PC board. It's because she wants food, and we're going to have to give in soon and apply her with some food, because if not, things will only get worse. And usually my hand gets a little bit of a nibble, which is a reminder that you're not offering any form of service, i.e. food things. So the other thing is the voltage selection on this amp is set at 230 volts and not 240, so it's never been changed over. And if we look here on the 240 volts, well, the 230 and the 240, we can see CP6 on 230 and 240, CP7 is the same on both, but CP2 on 230 volts is white black, and CP8 is black. They're the opposite way round on the 240. And I've actually looked in here. It's quite hard to see because these jumpers, these spade connectors are quite close together, but they're coming from the transformer. As you can see, white, black and black there. That is the primary going in there. So we've got 100, 220, 230, 240. So we've got these different primaries here. And then we've got the secondaries. Yes, Pink. So if we just look in there, I've pulled the black and white wire off, and you can see CP2. So if we look on there, you can see this amp is clearly set to 230 volts. You can see CP2 there is white black. So if you've got one of these and you want to swap the voltage round, you simply swap CP8 and CP2 round. So instead of having 2 and 8, you've got 8 and 2 there. So easy enough to do on this one. So we'll swap that over. Now when you do that, it will make the amp run a bit cooler. The bias will obviously, but it'll also reduce the filament voltages, and they're obviously overvolted on the filaments if it's set at 230, depending where the mains voltage is. Of course, I'm going to put that back on there now. Depending where the mains voltage is. Now at the moment we're 7 volts over 230 volts, but as the evening wears on, and it is early evening now, it's about 20 past 7, as the evening wears on, that will go up, and it'll finish up at about 242 volts. So right, I've got the amp switched on, and the standby is on. We don't need the standby off to the HT voltage. We're just measuring the filament current. So let's have a look. So already there, we're at 230, just pushing up to 237 there. We've got 6.74 on there already, so we're already over the 6.3. Not massively, but once that gets like 242, that's going to creep up to like 6.9, and that is too much then. So it just shortens the life of the tubes. So we need to change that, don't we? So let's go off onto standby now. So we're off standby. So now we need to just check some plate voltage. So we put the meter back there, and also spotted some stray wires on that cathode that weren't trimmed off on that cathode there, and again that's factory. 421. We've got 421 plate volts and 6.7 volts on the filament. So we'll turn off. We'll unplug. Right, we'll check there's no voltage in the amp before we dive in. No, that's fine, nothing in there. Right, so now we need to swap those two wires round. We've just got the camera at a bit of an awkward angle there, but so we'll remove that one, and then I think C8. Just have a look, is that C8? Yep, CP8. So we put CP black and white on CP8, and we put black on a CP2, like so. And then what we do is we go back to our schematic and we double check. Always double check. CP8 is now white black and CP2 is now black. CP2 is black and CP8 is there. Always go back, check your work, especially, you know, this is a really expensive amp. Don't want to be blowing it. And just to be 100% sure, I'm going to start this on the current limiter, because it's just what I do when I've changed something. So now let's switch the amp on. Bet the fuse will blow now. No, it doesn't. So we'll leave it in standby. So why do I leave it in standby when I'm only measuring the filament voltage? Well, the pin, you know, if you make a mistake and bridge a plate to the filaments by mistake with your meter probes, then obviously that's not going to be good. If you don't need the HT voltage on, then you might as well just switch it off. You're only measuring the filament, so it's just safer. It's just covers errors. Everyone makes mistakes. That's the worst one you can make, you know, causing a short. So by leaving the HT voltage off, you just prevent that. Right, so current limiter's off. Now let's look at the plate voltage now, the filament voltage. So we're on AC. So let's have a look. And there we go, 6.49. So that's gone down. We're at 2. It's not gone down a lot though, has it? That's not, you know, you're not sort of looking at that and thinking that's tumbled. But it's in the ballpark again. Right, yeah, with a bit of patina on that or something. I'm struggling to get a reading off that. There, 6.47. So yeah, it's down, but it's not massive. And again, we're at 237.5. So it's much better. It's in its ballpark. That's good. So we sorted that. Now let's see what we've got on the plate voltage. And now I've only got 407, look. 406. So look at the voltage we've dropped off there. So yeah, 421 before, and now it's 406. And there you go. It's a good job I was born with a menial amount of talent, because of my severe lack of good looks. So, enough waffling. Switched off again. Just make sure that voltage has disappeared again before we start delving in. Yeah, that's going down, you can see. So yeah, we're fine. So that's sorted that problem out. I've spoken to the customer, and he's going to have those IC cats removed, and I think that makes sense. So there's still one or two more puzzles to solve in this amp. So that gets rid of the... Oh, and incidentally, I've got two schematics here. I've got the 68 custom and the 65, and this is same on both of them. So it doesn't matter which one you've got. I checked on both schematics, and that's the same. So if you've got one of these, if you look at that now, because this is part of the schematic that I've enlarged to... What I do is I enlarge as I print them out, and I don't know if I've got the original size schematic amongst this lot. I've got pages here, probably end up getting them all mixed up. So yes, if that is the original size schematic, and this here is the voltage on there, and I've just blown this up in sections. So if you look at that and you've got one of these and you live in the UK, this only applies if you live in the UK, of course, because in the States you're at 110 volts. So this only, and I think these are export models anyway, because 100 volts, now correct me if I'm wrong, and if good, and if you're watching this, I'm sure you'll have the information, is 100 volts for Japan. 220 volts is, I don't know, where anybody knows that, leave that in the comments. It's all interesting info. 230 volts is EU, and obviously here but not here, or it's supposed to be here but it's not, and 240 is us. That's where we are supposed to be, and that's where we are now. So that's done. So, you know, pause the video, take a screenshot, whatever you want to do, that simple enough. There you go. So that's that. And if you take a screenshot, you can look at it without me waffling, which is something I'm very good at. Waffle. So this is the 68 custom schematic, which is this supposed to be this amp, because this amp is a 68 custom deluxe reverb. According to the manual, and the fascia panel on the manual on the front page looks the same as well on this amp, so which on the 65 it's different. Only the writing's different, the controls are the same. Now I have got a section of that blown up, and this you can see here, if you see that, and that is quite tough to see probably from there, but on here, down here and there, you've got, you see that line. Well, if I blow that up, that is that. So what's happening here, we've got the two channels going in there, and vintage and custom. You can't see that writing, but it is custom. You can see that this is this is a blow up of the 68 custom deluxe reverb, and this is the channels coming in. So we've got triode here, and that goes into the triode here. And if we get something to and this is a bit tricky because trying to do this from the side, because obviously this is in front of the camera. So we're coming in here into this grid on the custom channel, we're going up through the plate, we're going, there's a tone stack, and we're coming out of the treble there on the wiper, we're going down here into the volume, into this second stage, and then the second channel is coming into the grid, out of the plate, through the tone stack, into the volume, into another triode there. So we've got equal amount of triodes, 2 triodes for each channel there. And then this wire here is linking those channels, and they then go off into this triode here. Now, the relevance of all of this, from what I can see with this amp, and someone, you know, in the States that's worked on these regular or knows a lot more about them than me, and as I've said before, I don't geek out on amps, I just mend what lands on my bench, and I quickly forget all the ins and outs. I'm not one for logging every single part, but I do, obviously, when I'm looking at things and looking at schematics, I see things that don't tally up. So if you were linking these two channels together, obviously they need to be in phase. So if we thinking of this, we need the equal amount of triodes to be able to link these channels. And then both channels are going into that one, and that one then goes on to the phase inverter, and then the reverb and the tremolo and everything is in with that, linked in various places. But we're not really looking at that. We're just interested in this channel situation. So this is from the 65 Custom Deluxe Reverb. And if we look, so we've got triode there going in, coming out the triode, through the tone stack, there, through the treble, into this triode here. So you've got your two triodes. And if we come to the vibrato channel, we're going through this triode and out, through the treble, as usual, there, into the second triode. But then this channel, the vibrato channel, goes into a third triode there. And then if we look, that comes out of that triode there and goes up to that 220k mixer resistor. This channel then has come to a 220k mixer resistor, and you can see that those two channels have joined there, and then they go off into the phase inverter. So in my book now, that makes these two channels out of phase with one another, and so you can't link them. But if we look in this amp, remember this is the 65, from the 65 schematic. The other one we looked at was from the 68. This amp that we're working on is a 68 custom. But if we look in this amp, we can see that R12 there is missing, which is one of the 220k mixer resistors. There's the other one, and we can see that that's been disconnected there and connected onto the 47 ohm resistor there, which is R53. And I checked that with a meter, and that's wired on the ground side. Now if we go to the 220k mixer resistors, there's R12, which has been removed, and so in actual fact removing R12 has disconnected this line here. So now I've just got the coupling capacitor, and that's gone all the way down here and connected to here, this 47 ohm resistor on the ground side, which then goes in to the grid on there. So that now gives us 3 triodes for the normal channel, so 1, 2 and 3, and 3 triodes for the vibrato channel. This seems to have the 65 board in it, but yet we've got these mods, and the 68 board doesn't correspond to this. It's different again. You can see a resistor here that has been glued onto that capacitor. That was added by the previous tech, and that is this. So that's been bridged over R64, and R64 is here, and that is the negative feedback resistor. So apparently he has changed that value by adding that resistor to what the original deluxe reverbs were, which he's put in his notes that is to reduce noise floor on there. So that's why that's been done. So that's basically where we are with it. Once we've got this amp recapped and everything, we're going to run it up again. If the fuse blows, we're going to go for changing the rectifier tube. Well, the fuse probably will blow again, let's face it, although it hasn't blown for a considerable time. We're going to go for a rectifier tube. So thanks for watching and putting up with me waffling, and you all take care, and I'll see you all in the next one. Bye bye for now.